Hello, this is Kelly Cordova for MBE 580 Supply Chain Management with Dr. Paul Ewell. My major course project is about Tesla. There are a few key points that I will discuss in the presentation. First, Tesla is a vertically integrated company. I will discuss what that means and how it affects Tesla's supply chain and distribution. Second, we will take a closer look at the production of Tesla's Model 3. The Model 3 is the latest of Tesla Automotive's models. Tesla believes that the Model 3 is an electric car for everyone. It is their goal to make the Model 3 the best-selling midsize sedan in America, electric or not. The production of the Model 3 has been riddled with supply and operation issues, so we'll take an in-depth look at that. Third, we will look at the solutions Tesla is utilizing to solve their production issues with the Model 3. And lastly, I'll make some recommendations for the future of the Model 3 production. First, a brief history about Tesla. Tesla is an electric automotive company that builds its cars in Fremont, California. It also has a solar energy plant in New York. It was founded in 2003 by Martin Eberhard and Mark Tarpenning, although many people think that its flashy current CEO, Elon Musk, is the founder. Tesla went public in 2010 and was the first American car company to do so since Ford in 1956. Tesla's production philosophy is: fundamentally, we believe that thinking about a factory in the same way that people think about the product itself creates the potential for a step change in manufacturing that will create enormous benefits for quality, cost, efficiency, and employee safety. We will see this philosophy in play as we explore Tesla's supply chain and production model. While most modern automobiles are assembled from parts made by hundreds of suppliers in countries all over the world, and in some cases the cars are even finally assembled even in some cases the final assembly of cars is done under contract, Tesla is estimated to be 80% integrated. While most other car companies simply focus on the assembly process and engine manufacturing, Tesla owns and operates its own factories, dealerships, and service centers. Tesla builds its own batteries, power electronics, drivetrain systems, and even more mundane things like seats. Beyond vertically integrating much of its supply chain, Tesla is also vertically integrated through its direct-to-consumer sales strategy. Once the cars are made, Tesla sells them direct to consumers through their website and corporate stores. Tesla founders Eberhard and Tarpenning realized that a startup didn't want to sell through dealerships. They would lose opportunities to gather feedback from company customers if they did so. Moreover, they learned that a company has few options if a franchise fails to deliver, since all 50 states have laws on the books protecting franchisees. As of April 2018, Tesla had 339 stores and service locations worldwide, with plans for even more every quarter. Tesla also had a total of 1,205 supercharger stations worldwide to support the cars of their growing consumer base. Tesla says that they sell their cars directly to consumers for several reasons, including the ability to educate consumers on Tesla and electric cars, as well as to have small showrooms and high foot traffic areas to generate interest instead of large car lots to generate sales. This last point helps them keep their inventory low, as there are not massive Tesla dealerships around the world that the company has to stock. Instead, consumers order the cars from the small showrooms or online. This helps Tesla keep their costs down. Here's a SWOT analysis of Tesla's vertical integration. Strengths. For other car companies, outsourcing supplies and parts makes sense for commodity items that will not change significantly. But for Tesla, who is literally innovating parts it needs with Silicon Valley brainpower and speed, the products that contain unique and intellectual property or that are expected to change quickly, building them in-house can be the best choice. Tesla believes that one of the advantages of a vertically integrated supply chain is that continuous process improvement can happen as improvements are ready. Tesla claims that they are able to make up to 50 minor changes a week, increasing efficiencies faster than their competition. By selling cars directly to consumers, there are lower costs associated with sales, and the company has the ability for direct consumer feedback without a middleman, as previously discussed in the slide before this. Some weaknesses. In some cases, Tesla is trying to reproduce parts of a production line that were created by Henry Ford back in the early 20th century. By not relying on suppliers that have figured out the kinks of producing car parts en masse, Tesla is putting itself behind its competitors. By reinventing the wheel, Tesla is spending time and money that its competitors do not have to. Opportunities. There's an opportunity for continued in-house innovation when much of the production is done under Tesla's watch. Tesla also reports that it sometimes employs a layered capacity strategy, where it starts by building a product with its own small manufacturing operation, using this pilot line to develop an understanding of what it takes to build the product. As capacity scales up, production can be outsourced to contract manufacturers. Threats. The biggest threat to Tesla's vertical integration is Tesla itself. When production of one part doesn't go right, they don't have other suppliers to turn to help them increase capacity. Once they are behind in production, they stay behind in production for a long time. Tesla has had a lot of production issues with the Model 3 that we will discuss later in this presentation. These issues outline exactly how Tesla's vertical integration is a threat to itself. In this next chapter, we will discuss Tesla's overall supply chain and production strategy. Tesla's Gigafactory 1 in Sparks, Nevada is part of its vertical integration. Elon Musk refers to it as the machine that builds the machine. The Gigafactory stretches 5.5 million square feet, which equates to the size of 35 Costco stores, and the Gigafactory is only 30% complete. Once it's finished, it could be the largest manufacturing plant in the world. Tesla decided to build the Gigafactory when it realized that it would need more lithium-ion batteries than any one supplier could give them. Once its Gigafactory is fully operational, which Tesla projects will happen in 2020, it will produce more lithium-ion batteries a year than all other lithium-ion battery manufacturers created in 2013 combined. The Gigafactory has cost the company at least $5 billion to date to build. In the Gigafactory, Tesla partners with Panasonic to manufacture the customized lithium-ion batteries it installs in its products. This partnership with Panasonic is an important part of Tesla's strategy, as producing the batteries from the raw materials in-house allows Tesla to keep the cost of producing batteries down, which in turn keep the cost of producing cars down. Tesla estimates that once the Gigafactory is fully operational, it will reduce its battery costs by 30%. Tesla's Gigafactory produces more than just car batteries. The factory also produces its Powerwall and PowerPack batteries. Both of these batteries are designed to harness natural energy, either solar or wind, to power electricity. Tesla partners with Panasonic for both of these products too. The picture is of a Tesla Powerwall. Tesla has plans to build its next Gigafactory in Europe, although the exact location has yet to be determined. This location will be a dual battery and vehicle manufacturing plant. The company has publicly stated that it could build as many as 5 Gigafactories around the world in the future. Tesla batteries are made from raw materials such as lithium, nickel, cobalt, and aluminum oxide. The exact makeup of raw materials is in this graphic. Lithium and cobalt have been in the news of late. First, the rush to secure long-term contracts with lithium producers is something companies like Tesla are desperately trying to do. 75% of the world's lithium is mined in Argentina, Chile, and Bolivia. This region is referred to as the Lithium Triangle. Cobalt has seen a price surge in the last year due to the projected demand for electric cars. Cobalt production and pricing is subject to the volatile country of the Democratic Republic of Congo, which mines 60% of the world's cobalt supply. Over half of the world's nickel is mined in Indonesia. In 2014, Indonesia banned the export of nickel, which caused the price to spike nearly 50%. Here is a graphic showing where the raw materials are sourced. According to the graphic, Tesla has stated that they wish to source 100% of raw materials sustainably and ethically from North America. The problem is that the only significant supply of raw materials needed to create batteries is nickel, which can be found in Canada. The U.S. has not mined cobalt in over 40 years, and the U.S. produced no graphite in 2015. There is a lithium brine operation in Nevada, just miles from the Gigafactory. However, it only produces 1,000 tons of lithium hydroxide per year. This is not enough to satisfy Tesla's operation. So Tesla's dream of sourcing all the raw materials from North America may be just a dream after all. Here is a graphic showing the average price of raw materials needed for electric car batteries. As you can see, the price for cobalt has surged, and it is a critical raw material for battery technology. Nickel remains expensive, although it is a more abundant, cheaper material. Despite all these potential issues with sourcing raw materials for batteries, Tesla has been successful in doing so thus far. Once they have all the raw materials, here is an example of the Gigafactory's process flow for battery production. As you can see, the Gigafactory takes the raw materials and converts them into different parts of the battery, and then assembles the cell, and then combines the cells into a battery pack. Some of the raw materials go into the batteries themselves. Some are used directly in the cell, module, and pack assembly. Assembled batteries leave the Gigafactory in Nevada by truck and are transported to Tesla's car assembly plant in Fremont, California. You will notice that the Gigafactory also has a battery recycling in its process flow. This is an example of reverse logistics. Besides the Gigafactory, Tesla reportedly uses around 300 suppliers worldwide, many in the United States. Here are some examples of their suppliers. Besides Panasonic, most of these suppliers ship their Tesla components directly to the car assembly factory in Fremont. It's also important to note that Tesla acquired SolarCity in November of 2016, thus adding to the vertical integration of Tesla's supply chain. Beyond the Gigafactory, Tesla has several other manufacturing and tooling facilities. A casting foundry in Lathrop, California, which is near the Tesla assembly plant in Fremont, a tool and die plant in Grand Rapids, Michigan, the SolarCity plant in Buffalo, New York, and a final assembly factory in Tilburg, the Netherlands, for the European market. These factories make Tesla different in two ways. Number one, many of their factories are located in the United States, which is almost unheard of these days for an automotive company. And by owning these factories, Tesla has vertically integrated its supply chain, another unheard of value for most car manufacturers. We will continue in part 2 of this presentation with an in-depth look at the production of the Model 3.